In this video, we will learn to create a sample Codova app using Intelij. Intelij is quite helpful in creating mobile apps using Codova. We are aiming to create a Hello World app that will have some sample text. To create a Codova app in Intelij IDEA, let's open the IDE first. Let's click Create New Project. Now select Static Web from left-hand side option. Now select PhoneGap/Codova app option and click on Next. Now let us provide a name to the project. Let's say Hello World. Next, we need to choose a location of our project. I'm keeping this as default. At last, we will select type of project. Let's select Codova from the drop-down. Now click Finish. As you can see, the project is getting created. Let's wait for the process to complete. And as you can see, Hello World project is created. So in this video, we have learned to create a sample Codova app using Intelij. In this video, we will learn how to configure jQuery Mobile in an Intelij IDEA project. To configure jQuery Mobile in an Intelij project, you can simply download the package or reference the package from CDN. To add IntelliSense support in Intelij, you need to configure the library in Intelij. To add the support, open Preference panel by opening Intelij IDEA menu and Preferences. Now select Languages and Frameworks, JavaScript, Libraries, and in the right hand side, click Download button. Now select TypeScript Community Stubs. Now search the jQuery Mobile by clicking on the first and typing jQuery Mobile. Select jQuery Mobile from the list and click Download and Install. To add jQuery Mobile to your project, you need to include jQuery Mobile library in your HTML files. To start with, we have downloaded the jQuery Mobile package from https://jQuerymobile.com and have extracted output in the JS folder in our project. Now to include the library in index.html, let's add the following code. Script, language is JavaScript, type is text/JavaScript, source equal to js/jQuery.mobile. Let's select it from the list. jQuery.mobile. So IntelliSense is already helping us, and let's select the JS file. Let's close the tag. Now let's add the CSS style sheet for jQuery Mobile. Let's add link space rel, and I'll say style sheet, type text/CSS, href equal to double quotes JS/, jQuery mobile. Let's select it from the drop-down list. Slash jQuery dot. Let's select it from the list. We'll choose the CSS file. Let's save the file. So jQuery mobile is successfully integrated in your index.html file. So in this video, we learned how to configure jQuery mobile in a project. In this video, we will explore the Codova app structure generated by Intelij. So we have created an app, and you can see the app structure on the left hand side. The very first folder is .idea folder, and it contains Intelij configurations. Next, we have the hooks folder, where you can add hooks which are scripts or code snippets that is executed during the build process. Hooks allows you to extend the Codova framework. For example, if you want to copy icons and splash screen during the build process, hooks can help you. Next folder is the platforms folder, which is currently blank, and you can add specific platform that you're targeting for your app. Next is the plugins folder, where you can add plugin for the native functionality like camera, which you want to use in your app for a specific device. The next folder is the www folder. This folder will have your HTML codes. When Intelij creates the structure, it will automatically create a sample HTML app with complete source code for your reference. Let's look at the structure in more detail. The CSS folder will have all the styles used in the project. The img folder will have all the images. The JS folder will have the JavaScript file used in the project. The lib folder will have the library you want to incorporate in the app. Currently, as you can see, the Ionic library is by default part of your project. The templates will have specific Ionic templates pre-packaged with the app. Next, we have a config.xml, which will have the entire configuration needed for our app. In this video, we have explored the Codova app structure generated by Intelij. We will learn how to add a target platform to your app in Intelij. Before we proceed, make sure that the Android SDK is configured in your machine. To start with, we have created an app and opened in Intelij. To add Android SDK path in Intelij, open File, Project Structure. Now, under Platform Settings, select SDKs. Let's first add Java SDK. Click on the plus icon and select JDK. The Intelij will automatically find the library and also auto-populate the path. Now let's click on OK. Now click plus icon again to add Android SDK if it is not already there. Now select installed Android SDK directory. I'll choose users, SC, which is my username, library, Android, and SDK. Now click OK. Let's click OK for the version confirmation dialog box and click OK for the changes to get affected. So we are all set. In case you see any warning related to missing Android SDK, please restart Intelij IDEA. Now we will explore how to add Android platform. To do so, open Run, Edit Configurations, select PhoneGap Codova Run from left, and select Platform from drop down on the right. Here you can select Android or iOS or other platforms using more options. Let's select Android and let's click OK. Now to apply the changes, let's run the project. Click on the run icon. Now the project will run in an Android simulator. Let's wait for the simulator to open. So the simulator is now opening. So as you can see, the Android platform is now added to the platform folder. So in this video, we have learned how to add a target platform to our app in Intelij. We will learn how to publish an app using Intelij. Let's open the Intelij IDE. We have already created a project called My App. Let's open the project. Let's try to publish the app for Android. To publish the app for Android, first of all, we need to select target platform. To do so, open Run, Edit Configurations, select PhoneGap Codova Run from left and select Platform from drop down on the right. Here, you can select Android or iOS or other platform using more options. Let's select Android. Now let's click OK. Now let's publish the app. To publish the app, simply run the app in targeted platform, which is Android, as we have selected this earlier. Let's click on the Run button. Let's wait for the build to complete. So the Android simulator is now open on the right side. Let's wait for the app to open on the simulator. So you will notice that platform Android is added in platform folder on left hand side, and the app is open in the simulator. Now let's explore the platform folder. So as you can see, inside Android in platforms, there is a folder called build. Let's open it. Let's open the outputs folder. And as you can see, the app is successfully published for Android as android-debug.apk. We can install this APK file in our Android device. So in this video, you have learned how to publish an app using Intelij. In this video, you will learn about the core configuration elements in config.xml. Config.xml acts as a global configuration file to control different aspects of the app's behavior. You can locate the file inside the app root directory after you create the app structure. Let's look at the config.xml and explore the various nodes. In this video, we will explore the widget node, which is supported across all available platforms. There are two attributes of widget node. First is ID, which will have the app's reverse domain identifier. Second attribute is the version number, expressed in major or minor patch notation. The widget tag can also have attributes that specify alternative versions, namely version code for Android, C bundle versions for iOS, and package version for Windows. Let's look at some of the elements that are inside the widget node. The name element will have the app's name, which will appear on the device home screen and within app store information. The description and author elements specify description of the app as metadata and contact information that may appear within App Store listing. The optional content element has the link of the app's starting page in the top level web asset directory. The default value is index.html, which appears in a project's top level www directory when you create your app through CLI. Access elements define the set of external domains the app is allowed to communicate with. The default value shown above as star allows to access any server. You can also explicitly define the value for a particular domain, example http://google.com, or if you want to access all subdomain of Google, you can use http://star.google.com. So in this video, you have learned about the core configuration elements in config.xml. In this video, you will learn about the preference tag in config.xml. Preference tag can be used to customize your application configuration. All preference tags in your config.xml are copied to the platform-specific configuration files, which means that any preferences supported by the Codova framework or by any plugins you are using will work on Codova build. There are two kinds of preference. The first one is a global preference, which is accepted by all platforms. Let's look at the global preference tags. Preference with the name value full screen will allow your app to hide the mobile OS default status bar at the top of the screen. Next is orientation, which will set the device orientation. Possible values are default, landscape, or portrait. Please note that the default means both landscape and portrait is enabled. If you want to use each platform's default settings, usually portrait only, remove this tag from your config.xml file. The next type of preference is multi-platform preference, which work in more than one platform. Let's look at some of the preference tags. Disallow overscroll enables you to disable the interface to show feedback when users scroll past the beginning or end of the content. The value can be true to disable the feedback and false to enable the feedback. Background color can set the app's background color. The value accepts a 4-byte hex value, with the first byte representing the alpha channel and standard RGB values for the following 3 bytes. This is only applicable to Android and BlackBerry. Hide keyboard from accessory bar can be used to hide the additional toolbar that appears before the keyboard, helping users navigating from one form input to another. The value can be set to true or false. This applies to iOS and BlackBerry. So in this video, you have learned about the preference tag in config.xml. In this video, you will learn about the feature element and the platform element tag in config.xml. If you use the CLI to build application, you have to use plugin command enable device APIs. This does not modify the top-level config.xml file, so the feature element does not apply to your workflow. If you work directly in an SDK and using the platform-specific config.xml file as source, you will use the feature tag to enable device-level APIs and external plugins. They often appear with custom values in platform-specific config.xml. For example, here is how to specify device API for Android projects. You have to create the feature tag with the name attribute as device. Next will be the param tag with the name as Android package. to specify that this is targeted for Android, and the value attribute as org.apache.codova.device.device to specify the device API. In the next line, we have an example to show how the element appears for iOS projects. We have created the feature tag with name attribute as device. In the next line, we have the param tag with name attribute as iOS package to specify the targeted platform, followed by value parameter as CDV device to specify the device API. Now, let us look at the platform element. When using the CLI to build the application, it is sometimes necessary to specify preferences or other elements specific to particular platform. Use the platform element to specify configuration that should only appear in the single platform specific config.xml file. For example, here is how to specify that only Android should use the full screen preference. Create the platform tag and in the name attribute specify Android, followed by the preference tag, and in the name we have used full screen and the value as true. So in this video, you have learned about the feature element and the platform element tag in config.xml file. You will learn how to configure your app's icon for iOS and Android platform through config.xml. We have already published a sample app structure through Codova CLI in the desktop. Let's open the folder. I have kept the icon images inside a folder called res. Inside res, there are two folders, Android and iOS, which have the respective icons for each platform. Let's open the config.xml in your app's root folder. First, let's look at the syntax for declaring an icon. The icon can be defined by declaring an icon tag. The icon has a set of attributes. Let's look at them one by one. In the source attribute, you have to specify the image location of the icon. The icon can be either in JPEG or in PNG format. The platform attribute has the name of the platform for which the icon is targeted. This is an optional attribute. The width attribute will set the width of the icon in pixels. This is an optional attribute. The height attribute will set the height of the icon in pixels. Again, this is an optional attribute. Density is an Android specific attribute and is optional. This specifies icon density in predefined values. You can also define pixel perfect icons for each platform supported by Codova. Let's look at an example for Android and iOS. To start with, we have defined a platform node with the name attribute as Android, which is the name of the platform. Inside the platform node, we have included the 6 icon tag to define icons for 6 different resolutions. Now, Android uses the density tag to declare the resolution. The number of dots or pixel per inch that an Android device's screen holds determines how sharp the image on the screen looks. The more dots per inch, the sharper the image. Android groups screen densities into several classes. These are referred to as MDPI or medium resolution devices, HDPI, high resolution devices, XHDPI, extra high resolution devices, XXHDPI, extra high resolution devices, and XXXHDPI or extra high resolution devices. There is also a low density class LDPI. However, not many new devices have a low density screen, and thus LDPI is no longer important. MDPI is around 160 dpi. HDPI is around 240 dpi. XHDPI is around 320 dpi. XXHDPI is around 480 dpi. XXXHDPI is around 640 dpi. And LDPI is around 120 dpi. It is the screen density that determines the Android icon size used. Please check the specification of your target devices to know the exact DPI. So in the first icon tag, we have used the value LDPI, which translates to dimension 36 pixels of width and 36 pixels of height. In the second icon tag, we have used the value MDPI in density value, which is the dimension of 48 pixels of width and 48 pixels of height. In the third icon tag, we have used SDPI in density attribute, which is of the dimension of 72 pixels of width and 72 pixels of height. In the fourth icon tag, we have used XHDPI in the density attribute, which is of the dimension 96 pixels of width and 96 pixels of height. In the fifth icon tag, we have used XXHDPI in the density attribute, which is of the dimension of 144 pixels of width and 144 pixels of height. And finally, in the fifth icon tag, we have used XXXHDPI, which is of the dimension 192 pixel of width and 192 pixel of height. Now, let's look at how to define the icons in iOS. Again, we have used the platform tag with the name value as iOS. In iOS, you can straightaway declare the size of the icon inside the tag. The first icon is for iPhone 6 Plus, which has a Retina display. The width of this icon is 180 pixels and the height is 180 pixels. The next icon is for iPhone 6s, iPhone 6 and iPhone 5, where the size is 60 pixels by 60 pixels. In case you are targeting Retina display for the versions of iPhone, you will add @2x, and the dimension should be 120 pixels by 120 pixels. For iPad Pro, the dimension is 167 pixel by 167 pixels, and for iPad and iPad Mini, the dimension is 152 pixel by 152 pixel. For iPad 1, the dimension is 76 pixels by 76 pixel. So in this video, you have learned how to declare icons for Android and iOS. In this video, you will learn to implement splash screen for iOS and Android in your app. We have already published a sample app structure through Codova CLI in the desktop. Let's open the folder. I have kept the splash images inside a folder called res. Inside res, there are two folders, Android and iOS, which have the respective splash screens for each platform. Let's open the config.xml file in your app's root folder. As Android, which is the name of the platform. Android uses density tag to declare the targeted resolution. There are 6 types which are created based on the dots per inch or DPI. LDPI, which is targeted for 120 dpi screens, MDPI, which is targeted for 160 dpi screens, HDPI, which is targeted for 240 dpi screens, XHDPI, which is targeted for 320 dpi screens, XXHDPI, which is targeted for 480 dpi screens, and XXXHDPI, which is targeted for 640 dpi screens. Let us look at how to implement the landscape splash screen for various resolutions. Now in the first node inside the platform node, we have created the splash node with the attribute source, which has the path of the splash file, and the density tag defines the type of splash. In this case, this is for landscape HDPI. This splash for landscape HDPI will be of the dimension 800 pixel by 480 pixels. In the density attribute, we have used land-HDPI. In the second node, we have created the splash node for landscape LDPI with the path of the splash image and density as land-LDPI. The dimension of the splash file in this case is 320 pixels as width by 200 pixels as height. In the third node, we have used the density value as land-MDPI, which is targeted for landscape MDPI. The dimension of the splash for this case is 480 pixels by 320 pixels. In the fourth node, we have used the density value as land-XHDPI, which is targeted for landscape XHDPI, and the dimension of the splash is 1280 by 720 pixels. Now let us look at how to implement the portrait splash screen in Android for different resolutions. Again, we have created a platform node with the name as Android. In the first node, we have used the value port-HDPI in density attribute, which targets the portrait HDPI. The dimension of the splash image should be 480 pixel by 800 pixel. In the second node, we have used the value port-LDPI in density attribute, which targets the portrait LDPI. The dimension of the splash image should be 200 pixels by 320 pixel. In the third node, we have used the value port-MDPI in density attribute, which targets the portrait MDPI, and the dimension of the splash image should be 320 pixels by 480 pixels. In the fourth node, we have used the value port-XHDPI in density, which targets the portrait XHDPI orientation, and the dimension of the splash image should be 720 pixels by 1280 pixel. Now let us look at how to implement the splash screens in iOS. Again, we have used the platform tag and the name value as iOS. In case of iOS, we have to name the splash image file based on the iOS device we're targeting. So in the first tag, we are targeting non-retina display iPhone devices. So we have to create the name of the file as default tilde iphone.png and the dimension as 320 pixels by 480 pixels. In case of retina display iPhones, which is shown in the next line, we have to use default @2x tilde iphone.png, where default @2x means all retina display and tilde iPhone means for all iPhone. In this case, the dimension is 640 pixels of width and 960 pixels of height. We similarly defined splash images for iPad portrait orientation with resolution 768 pixels by 1024 pixels. In this case, the file name with default-portrait is to explicitly mention that this splash image is for portrait orientation, and tilde iPad is to specify the targeted device, which is iPad. In the next line, we have created the splash portrait image for retina display by using 2x in the file name and size is 1536 pixels by 2048 pixels. Similarly, we have created the landscape for iPad with dimension 1024 pixel by 768 pixel and landscape for retina display iPad with dimension 2048 pixels and 1536 pixel. When you publish your app, all the splash images will be copied to their relevant folders and entries will be transferred to device level config.xml. In this video, you have learned to implement splash screen for iOS and Android in your app. In this video, we will explore 9-patch PNG guide for Android. The 9-patch image is stretchable, repeatable images, which is reduced to their smallest size. If you're planning to create icons, it is always recommended to use 9-patch image. A 9-patch drawable is a standard PNG image that includes an extra 1 pixel wide border. This must be saved with the extension .9.png. The simplest example would be if you were to take a rounded div and slice it up into 9 squares. The 4 corners will not change sizes at all, but would be static, while the other 5 pieces would be stretched or repeated to allow the whole image to scale appropriately. I have opened an image for 9-patch guide. 9-patch works with PNG transparency to do an advanced form of 9 slice or scale 9. The guides are straight 1 pixel black lines drawn on the edge of your image that define the scaling and fill of your image. By naming your image in the format as your file name followed by a dot and then number 9 followed by another dot and then the extension PNG, Android will recognize the 9.png format and use the black guides to scale and fill your bitmaps. Now, as you can see in this image, there are guides on each side. The top and left guides are for scaling. Right and bottom guides indicates the fill area. The black guides will be automatically removed by Android and will not render. The guides must be 1 pixel wide. Now, Android provide a very easy way to convert a regular PNG to 9-patch graphics. Let's look at that. Please open users folder in Finder. Find the current user folder. In my case, this is SC. Then let's go inside library and inside Android and inside SDK and inside tools. Now double click to open the Draw9 patch file. I have already created an icon in the desktop. Let's open the image. Let's click on File, Open 9 Patch. Let's go to Desktop and open icon.png. In the left hand side is your image, and in the right hand side is the preview in different sizes when scaled. As you can see, the edges are getting dithered. Now let's fix it. I'll draw a boundary for the Android to interpret the 9-patch scaling. So I will right click and drag a boundary on the left of the image. As you can see, the preview scale images are immediately showing smooth edges. Now let's do the same thing in the bottom of the image. Okay, we are all set. Let's save our image by clicking on File, Save 9-patch, and let's save it in the desktop as icon. Let's open the image. And as you can see, two black borders are added to the image in the left and the bottom. You can use this image as icon for different scaling factors without any concerns of distortion. So in this video, we have explored the 9-patch PNG guide for Android. We will explore the common commands for Codova CLI. Let's open the terminal. First, let's explore how to create project through Codova CLI command. I want to create the app folder in the desktop. So let's type cd space tilde slash desktop and let's press enter. Now let's type the following command: sudo space Codova space create space my app space com dot example dot my app space my app. Let me explain the command. Sudo allows your command to run programs with the security privilege of the default super user. Codova command is the npm package you are invoking. Create will create the project. My app is the name of the directory where your project files will be generated. com.example.myapp provides your project with a reverse domain style identifier. My app is the name of your project. Now let's press enter. This will ask your system password. Please enter your password. Now the command is successfully executed. Let's confirm. So as you can see, the project with the name My App is created in the desktop. Let's go inside the folder. Codova has created all the required files and folders to get you started. Let's switch to the terminal. Now let us look at some more commands. Let's type sudo space Codova space help and press enter. This command will display all available Codova commands and their syntax. Additionally, you can get more detailed help on a specific command. For example, to get help for the run command, you can type sudo space Codova space run space -help and press enter. Let's explore another command. For this, you have to go to the previously generated project folder. So let's type cd my app and press enter. Now type sudo space Codova space info and press enter. This command produces a listing of potentially useful details such as currently installed platforms and plugins, SDK versions for each platform, and versions of the CLI and Node.js. After installing the Codova utility, you can always update it to the latest version by running the following command: sudo space npm space update space -g space Codova and press enter. Now let's wait for the updation to complete. So as you can see, the command executed successfully. In this video, we have explored the common commands for Codova CLI. In this video, you will learn to add and remove plugin through CLI in your project. When you build a web app for mobile, it does not behave like a native app since it cannot communicate with the different hardware components of the device. For the app to communicate closely with various device level features, you need to add plugins that provide access to core Codova APIs. A plugin is a predefined code that provides an interface to the native components. More commonly, you would add a plugin to enable one of Codova's basic device level features. As of version 3.0, when you create a Codova project, it does not have any plugin present. This is the new default behavior. Any plugins you desire, even the core plugin, must be explicitly added. A list of this plugin, including additional third-party plugins provided by the community, can be found in the registry at codova.apache.org/plugins. You can use CLI to search for plugins from the registry. We have already published a project called My App in the desktop. Let's open the terminal and move to the desktop. Let's type cd space /desktop/my app and press enter. So now we are inside the My App folder. Let's explore the commands. If you want to search a specific plugin, for example, let's say barcode, you can use the following command. Let's type sudo space Codova space plugin space search space bar space code and let's press enter. Let's enter the system password. This will return all the plugins available for barcode. If you want to broaden your search, you can search using specific search keywords. For example, if you use only bar instead of barcode, you will get all the plugins with the name bar in it. Let's type sudo space Codova space plugin space search space bar and let's press enter. So as you can see, the search result produced all the plugins with the name bar in it. Now let's see how to add a plugin to your project. Let's type sudo space Codova space plugin space add space org.apache.codova.device and press enter. So this command will add the device plugin in your project. Let's open the myapp folder and confirm. Let's go to the plugins directory. And as you can see, the device plugin is successfully installed. Now let's look at how to remove a plugin. Let's type sudo space Codova space plugin space remove space Codova hyphen plugin hyphen device and press enter. This will remove the plugin that we previously installed. Let's confirm if the plugin is removed from the myapp project. So as you can see, the plugin is removed from the plugin folder. So in this video, you have learned to add and remove plugin through CLI in your project. In this video, you will learn to add and remove platforms in your project through Codova CLI. We have already created a sample app structure through Codova CLI create command and kept in the desktop. Let's open the terminal. Let's move to the myapp folder in the desktop. cd space ~desktop/myapp and let's press enter. Let us first look at how to add iOS in your Codova app. Let's type the following command: sudo space Codova space platform space add space iOS. Let me explain the command. Sudo allows your command to run programs with the security privilege of the default super user. Codova command is the npm package you are invoking. Platform indicates that you will run a platform specific command of Codova. Add will add the platform. iOS is the name of the platform we are installing. Let's press enter. You may have to enter your system password. The platform is successfully installed. Let's verify. Let's open our myapp folder and navigate to platforms folder. So as you can see, iOS is added to your project. Let's switch to the terminal. Now in the same way, we can add Android. Sudo space Codova space platform space add space Android. Let's press enter. So Android platform is added to your project. Now you might also need to remove a platform from your project. Let's look at the command to remove iOS from the project. Sudo space Codova space platform space remove space iOS. Let's press enter. So the command executed successfully. Let's confirm. So as you can see, iOS platform folder is removed from your platform directory. Now you can also get the list of platform added to your project. For this, you can use sudo space Codova space platform space ls, enter. So as you can see, currently we have Android installed in our project. So in this video, we have learned how to add and remove platform in your project through Codova CLI. In this video, we will look at some advanced CLI commands for plugins. We have already created a Codova project through CLI in the desktop called My App. Let's open the terminal. Let's move to the My App directory in the desktop. Let's type cd space tilde slash desktop slash my app and press enter. Now let us look at how to find which plugins are installed in your projects. So let's type sudo space Codova space plugin space ls and let's press enter. So this will display the list of plugins installed in your project. You can batch remove or add plugins by specifying more than one argument for each command. Let's type sudo space Codova space plugin space add org.apache.codova.console space org.apache.codova.device and let's press enter. So here we have successfully installed two plugins simultaneously. Now to install the latest version of the plugin, you can use the @latest prefix in the command. For example, if you want to get the latest version of console plugin, you can use, let's type sudo space Codova space plugin space add space org.apache.codova.console @latest and let's press enter. So this command will fetch the latest version of the console plugin. If the plugin is not registered at registry.codova.io but is located in another Git repository, you can specify an alternate URL. Let's type sudo space Codova space plugin space add space hub.com/apache/codova-codova-console.git and let's press enter. So as you can see, the console plugin is fetched from the Git location. So in this video, we have looked at some advanced CLI commands for plugins. You will learn to install Plugman and configure plugins through Plugman. Codova allows you to install plugins in two different ways. In the first method, you can use Codova command line utility to install plugins. The second method is by using a lower level command line interface called Plugman. This is primarily preferred if you're working on an individual platform centric workflow. Now let us install Plugman. let me open the terminal. Let's type sudo space npm space install space -g space plugman and press enter. Let's wait for the installation to complete. So plugman is successfully installed in a system. Let us confirm the plugman version. Let's type plugman space -v and press enter. So as you can see, the version is 1.0.5. Now let us look at how to install a battery status plugin in your Codova project. I have already created a project through Codova CLI called My App in the desktop and also installed Android platform in it. Let us type sudo space plugman space install space --platform space, which is Android, space --project. Now I'll give my location of the project, which is in desktop in My App folder. Inside platforms /Android space 2 hyphens plugin space. Here I will type the Git repository location, which is org.apache.codova.battery-status and press enter. So the plugin is successfully installed. Let's confirm the plugin. Let's open the My App folder. Go inside platforms, go inside Android, inside platform_www directory, and inside plugins folder. So as you can see, the plugin is successfully installed. Now to see plugman's help, let's enter plugman space -help and press enter. This will show you the help of plugman command. Let's see how to uninstall the battery status plugin that we have installed previously. Let's type sudo space plugman space uninstall space 2 platform space Android space 2 project space /desktop /my app /platforms /Android space 2 plugin space. Now I'll give the name of the plugin, which is Codova plugin battery status and press enter. The system may ask for your password. So the plugin is successfully uninstalled. In this video, you have learned to install plugman and configure plugins through plugman. In this exercise, you will create a project through Intelij IDEA Add Android and Java SDK in your Intelij project. Write hello world in the body of the index.html inside www folder. Add a platform in your Intelij project. Publish the app in an Android simulator. Now pause the video and perform the exercise. You can come back to the video to check the solution later. Welcome back to the solution. Open Intelij IDEA. Click on Create New Project. Click on Static Web in the left-hand side and select PhoneGap/Codova app. Now click on Next button. Let's type the project name as My First App and click on Finish. Now let's click on File, Project Structure, click on SDKs and click on plus sign, select JDK and click OK as Intelij automatically detects the JDK location. Now click plus icon again and click on Android SDK and open users, your username, in my case this is SC. Click on library, click on Android and select SDK and click OK. Click OK to select the version confirmation dialog box. Now click OK to apply the changes. Now let's open the www folder and open index.html. Now inside the body, let's enter a text hello world. Let's save the file by pressing Command plus S. Let's go to Run, Edit Configuration. In Platform, select Android from the drop-down and click OK. Now click on Play button. Let's wait for the project to get compiled. So as you can see, Android simulator is opening. Our hello world message is displayed on the top.